This is a lesson on precipitation reactions. You must have cations and anions. You cannot have just one or the other. If you have the positive ions, you gotta have the negative ions. Definition: a precipitation reaction is a double replacement reaction that will produce a precipitate. Not all double replacement reactions are precipitation reactions, but all precipitation reactions are double replacement. You have to have a precipitate form in order to have a precipitation reaction. You gotta have a solid. Solution has to be cloudy. To designate or show you that you have a solid or a precipitate, what you do is you place a S in parentheses after the element. So if you have BaSO4 and that's a solid, you put an S after it. If it is dissolved, if it does not form a solid, you put an AQ after it. So if you have an FeSO4, you would put an AQ, and AQ stands for aqueous, like aquarium or aquatics, which is Greek for water. Your homework assignment, you will see the problem looking like this. You'll be given two substances, and that's it. Do that react. What you got to do is you got to finish off. You got to switch places. AgCl plus NaNO3. So step one is switch places. Double reaction. Double replacement reaction. You gotta write the formulas down correctly. Ag is 1 plus, Cl is 1 minus, so that's correct. Na is 1 plus, NO3 is 1 minus, so that is correct. So the next step is check formulas. Which we did. Step 3 is the balanced reaction. 1 Ag, 1 Ag, 1 NO3 group, 1 NO3 group, 1 Na, 1 Na, 1 Cl, 1 Cl, so it's balanced. And the fourth step is to put down solids or AQs where needed. On the left-hand side, you'll always have an AQ because you always start with two clear solutions. Using the rule of thumb table, which we'll talk about later, you have to designate one or none of these as being solid. That's going to be a solid, and that's going to be aqueous. Why do precipitates form? Well, the answer is the ions are more attracted to themselves than to the water. And as a general rule, to figure out which ones do form a precipitate or which ones are aqueous is the rule of thumb table, which I'll talk to you about in class. Sample problems. NaNO3 plus K2CO3. You leave spaces before and after so that you can fill them in. You got to do step 1, which is switch. NaCO3 plus KNO3. If it's a polyatomic ion, bring the subscripts, otherwise you leave them behind. So that's step 1. Step 2, check the formulas. Na is 1 plus, CO3 is 2 minus, so you need Na2CO3. K is 1 plus, NO3 is 1 minus, so that's done. Next thing you do is balance the equation. 1 Na, 2 Na, so you need a 2 here. You've got 2 Na, NO3s, so you need 2 there. 2 Ks and 2 Ks, so you are there. As a helpful hint, on the left-hand side, they are always aqueous because you will always have a clear solution to start with. And then looking on your rule of thumb table, if it ends with NO3, it's always aqueous. Done deal. That's it. And then you look up on your periodic table NO3, not periodic table, your rule of thumb table, CO3. CO3 does not form a solid with the Na, so it too is aqueous. If both of your products are aqueous, you write down no PPT, which is precipitate. Another couple of examples. AgNO3 plus KBr forms. So that's the problem. Got to do the double switch. So KNO3 plus AgBr. 1 plus 1 minus, that cancels. 1 plus 1 minus, that cancels. So the formulas are written correctly. Balancing equations, there's one of everything, so that's balanced correctly. The left-hand side is aqueous. NO3, that's aqueous also. And looking on your rule of thumb table, the AgBr is a solid. So that's how you do precipitation reactions with cations and anions. That ends this lesson on